don't know if there's really anything new, was there?
No, it should all be a review.
Yeah. Have you
It
done the
looks like
homework?
we have quite a few questions on the quiz, though.
Oh, geez. Have you opened it
Well, I
already?
think, what's that?
Have you opened the quiz already?
No, I haven't yet. But just when I went through the review, it said that those questions would be on the group meeting quiz, and it made it sound like they would all be on the group meeting quiz.
Oh, no.
Maybe not. I hope they just chose a few key ones.
Yeah, that'd be nice. We'll see. I to kind of brush up for the test, I went through some of the older problems, and I don't even know what they're called. I guess the ones where you have to find like standard deviation and the variance and all that by hand, those can be tricky if you haven't done that in a while. So that might be something good to go over.
Yeah,
That actually might be on tonight's quiz, so I don't know.
it is.
So
I would imagine it is. I hope it is.
yeah.
Hey, you're back.
All right. So we're all here now. Do we want to go over any questions or anything, or jump into the quiz, or what do you guys want to do?
I'm cool jumping in.
Okay.
Yeah, I'm fine.
All right. This should be interesting. Let's see.
Sorry, I gotta get
Oh,
company.
there's only 34 questions.
34?
Yeah.
Oh boy.
Oh, yeah.
All right, let's do this thing.
Wait, this is lesson 8, right? Week 4, lesson 8.
Yep.
Okay.
Yeah.
Okay. So which are categorical? These ones, categorical just means it's not, numbers, and you can't compare them by subtracting or adding, right?
Uh-huh.
So I think the randomly selected toothpaste is one.
Yep.
Yeah.
I don't think the animals are.
Yeah. I think
Probably
it's
just that one.
yeah. Yep.
I think it's just a randomly selected, because age and year is a randomly selected vehicle in a parking lot. Yeah, you could compare that.
Yeah. Okay.
Or subtract.
So do you guys want
And
me to read the questions, or who's?
Just so
who's
you know, guys, on the review, these questions are the review questions.
Oh, are they? Okay.
Yeah,
For the review test that we just did, this is the same ones.
yeah, so we should just be able to hopefully go through them.
Okay.
So number 2 is B, a randomly selected brand of toothpaste.
Yes. Mm-hmm. Okay.
The number 3 is the mean IQ test score. Which of the following statements is true? I can't remember.
Okay, so I looked up the difference between parameter and statistic. Statistic means it's not for an entire population, rather for a sample or whatever. And then a parameter is for it's the statistic for the entire population. So
Gotcha. So 100 is a parameter and 112 is a statistic?
There's a statistic, yeah.
Okay.
yeah. And so what's this question? Which of the following statements is true? So 100, there's no way they can take every single person's IQ. So that has to be a statistic. It can't be a parameter. And 112, it's for 20 randomly selected statistics students. That would be a parameter because it's for the entire group of 20, right?
Well, but isn't the mean IQ Wait, I'm confused.
So the mean IQ.
I thought you said the parameter was for the entire population.
Right. However, for the mean IQ in the United States, I don't think they could have really gotten the average from everyone. To do that, they would have had to have tested me, you, and
Every
every
single one,
person.
which they didn't. And they're just saying that the average.
Right. So it's not. Yes, it's saying it's for the entire United States, but really they didn't test everybody in the United States to get that number. That's just
right.
So.
Right.
And then it says that 20 randomly selected students for the scores. Okay, yeah, I could see that. I'm just curious whether they're saying the 20 randomly selected. It sounds like they are doing a statistic, like sampling of a larger population there.
Yeah.
I guess this depends on how you were thinking when you wrote the question.
Right. So I don't know. Yeah.
I'll go with your reasoning.
Okay.
Well, and we can click two, so.
Yeah.
We can click two answers, so.
So I think we should click the 112 is a parameter and 100 is a statistic.
100 is a statistic. Okay.
Yeah. Now if I'm wrong, I'm sorry. But I think that is right though. I do.
Well, maybe not. Never mind. If we select those two and it was the other two, then
What's that? Oh, one of us should do.
No.
Okay. All right.
All right. Sorry.
So number 4, or what do you guys want to do?
Yeah, I'm good with 3. I think that makes sense to me.
Okay.
Yeah.
So 4 says Rotham City has 4 distinct neighborhoods. The property values are very similar with each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property value and another has extremely high. Property taxes are usually roughly proportionate to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes? But would it be cluster, or would it be stratified?
Probably stratified, because cluster is when you put them into groups, but then you only survey one group, or you don't. I mean, you choose a group and survey the entire group.
Okay.
Stratified is where you put them into groups and you survey a sample of each of those groups, right?
Okay. Wait. Explain cluster again. I always get that one confused.
So cluster is when, with both of them, you're dividing them into groups. But with cluster, you say, for example, like here, you would say, okay, we're going to choose this neighborhood type. So maybe you have high, low, and medium property value groups, right?
Yeah.
You have those 3. If you did a cluster sampling, you would say, okay, we're going to go survey everyone in the high property value group and not in the others.
Right.
Gotcha.
Stratified is saying,
it's more even across the board.
Yeah. So stratified is saying we're going to go do a sample in each of those groups, but not the entire group.
Right.
Okay. So stratified would be best for this, I think.
I think so, yeah.
A stratified sample, right? Okay.
Yeah. Okay.
Probably 5. When designing experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all students in the selected classes. Which type of sampling scheme is implemented? That one is... Wait. Okay, now I remember.
Is that one cluster?
I think so. That's what I was thinking.
Because it's...
Yep.
So they put them into groups, and then they choose one of the groups, and then survey all of them.
And then they select all the students in those selected classes.
Yeah.
So that
Yeah.
that would make sense.
Like a double cluster.
Okay.
Yep, I think so.
Yeah, let's do that.
All right, I got 6. Well, I'll go after Bryce, and then Michael, you're after me.
Okay.
At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Jason was one of those. Which type of sampling scheme was implemented?
Isn't that just a simple random sample?
Yeah, because everybody did it. It was just everybody put their name in a hat, and
Yeah.
that makes sense. There wasn't any scheme involved or any kind of strategy.
Yeah. So just simple random sample. Okay.
Yeah.
So 7 says a special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. What type of sampling scheme was implemented? Is that stratified?
I think that's a stratified random sample.
Cool. Yeah, because they had the groups and then they surveyed a few in those groups. Cool.
Yeah. Huh. Not entirely sure the difference between a stratified sample and a stratified random sample would be, because it seems like if it was a stratified sample that's not random, you're just moving the entire population.
Oh, so there are two types of stratified samples. One's random and one's not.
I don't know. Well, before I think they're just well, I think it's just laziness. I think sometimes we call it a stratified sample, but I don't know how else you would necessarily do a stratified sample unless you did a stratified random sample.
Oh, right. Yeah.
I guess you could do a stratified clustered sample where you like choose clusters within the stratified groups and then do one of the clusters. But
Ugh,
anyway,
that seems too complicated.
yeah. Anyway, yeah, it's stratified. That was a side note. Sorry. A survey was taken of purchases at the crossroads. Open the data file Crossroads Purchases and use the data to answer questions 9 through 11.
Oh, gee.
Why are we on 8?
Yeah, right. Okay, so we have to open Crossroads Purchases.
Yeah. Did you guys do that yet?
No. Is it a time-consuming thing?
Well, I don't know. To be honest, I kind of went through the questions and like answered them in my head, and then I was like, we'll do them together. Probably
Yeah.
not, but
All right, let me try and find that thing.
I feel like it's more meaningful when we actually do things together. At least it helps me.
Yeah. True. Okay, let's see. Do you know what week that thing was from?
I think it's from this week. Oh, hey, I found it. Hey, I'll post the link.
Okay.
Let me see if I can figure out how to. Yeah, there we go. Can you see that?
Oh yeah. Okay. If I click on it, will it take me away from Google Hangouts?
I don't know.
No.
I tried to get out, and then I ended up having to hang up and call back. So.
Right click on it and say open a new tab, maybe.
Oh, are you on the computer? Are you on your Mac? Are you on the Hangouts on your computer?
I am, yeah.
I'm on a PC. Okay, let's see.
Mm.
Okay, so here it is.
Where did this take me? Oh, there we go.
With Crossroads Purchases. So.
Hold on, I gotta go check on my kids real quick because my wife's not home. Hold on.
Okay.
All right.
Hey, here's this other link that might be more useful.
Is that Oh, the direct one?
Yeah. I didn't realize it went to a page that you had to go find it.
Oh, it's fine. I just found it.
Okay. Alright. I got it up now.
We gotta do your thing, dude.
Okay, so when you open it on Excel, does it say like credit, cash, iCard, and all that
Yep.
in
That's
column
what it
A?
shows. Yep.
Yeah. Okay. So what exactly do we have to do?
Just to find the mean.
So find the mean. Jeez. So then do we also need to find that, not applet, but the other Excel thing that calculates mean and all that?
Oh yeah, you probably could. I'm just doing it by hand.
Like with a calculator?
Well, no, in Excel. I mean, by hand as in I'm just typing in the functions to do it.
Oh, okay.
But yeah, you probably could just plug it in there. I got 4.771.
If I want to add them all up, I could do auto sum, right? So it's
Yeah, I just do equals sum and then parentheses and then you select the range you want and then end parentheses.
Alright, guys.
And then you can also do, then I usually divide that by count of the same range. If that makes sense.
and then divide it by what? 86? Is that right?
Yeah. Here, I'll show you what I did. I don't even see that. That's what I typed in.
Okay, I got 4.77.
Oops. 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 Okay, what's going on here? Enter. Yeah, I got 4.771.
Cool, that's what I got.
Is that for 8?
Yeah, I think so. Let me get back in there. Yeah. 4.771. Okay.
Yep.
So now we have to do the standard deviation. Yeah, I think that one thing they give us would be easy for that. Unless you know how to do that on Excel without it.
Type in equals stdev and then select the range and give it to you.
How is it? I couldn't hear you.
Oh, I just the wrong button. You do something like that, and then in parentheses, that's where you put the range of the values. So that for this one, it ends up being that.
Oh, okay. So standard deviation. Oh, cool. Okay. Let's see. Okay. Did you get 1.9 1, 2?
Yep.
1.2. Okay.
Let's see. I'm trying to remember how to make a histogram.
I think I might remember. Let's see.
Just go up to, isn't it the, not cluster, but it's,
Column chart.
let me get in there. It's the scatter chart, right?
No. That's a different one.
3D surface. Contour.
Maybe I need to YouTube this.
I remember.
Cone. Oh. I haven't done that in like so long.
Actually, last time I did it in Google Docs, it was really easy. I didn't think I did it in Excel. I should figure out how to do it in Excel.
Oh, it's under the data analysis tab.
Oh, you found it?
What? Well, I just looked at YouTube or Google.
Sweet.
Sorry.
That's what I was gonna do too. So it's under
says
data.
Copy and paste the data into a new worksheet, and then in the data table or in the data analysis dialog box, click histogram, and then click OK.
So I just have a data tab.
I know I don't have a data analysis. I just have a data tab.
I'm not seeing it here. Let's see.
Oh. Huh. Oh, this is complicated. File. Functions.
Oh. Okay, so I wish I could show you what I'm looking at. Maybe I can actually. Hold on. Can you see my screen at all? Oh, you can. Okay, so under the data tab, see how it says data analysis? And then it says pivot table and what if?
Oh, hold on. I see your screen, but I'm not seeing the data. Like, try it again, I guess.
Well, no, I haven't done anything. I just opened up a new worksheet. That's all I did.
Oh.
But under the data tab, my data tab is highlighted, and then if you go to this, there's an analysis section, and that's a pivot table and a what if like a what if. That's just on what the Excel shows.
Okay, so I see the what if analysis.
So I just take the information and then I copy and paste the information onto like a new sheet, and then you send data table. Click on. Yeah, there you go. Okay, so input range.
Are you on Windows or Mac, Michael?
What?
I'm on Windows.
Are you on Windows?
Yeah, I'm on a Mac.
Oh, okay. Are you in Office 2013?
13, yeah. Uh-huh.
Histograms are not enabled by default. I found out.
Yeah, you have to get something extra for them. You have to get like like an add-on thing, which costs quite a bit of money.
So here, let me show. Can you see my screen?
Uh-huh.
Yeah. Mm-hmm.
Okay, hit File, and then Options, and it'll bring up the window. I don't know if you can see the window right now. Probably change that. Okay, can you see that window? It'll say Excel Options.
Okay.
Now go to Add-ins.
When am I gonna?
I'm on a phone call, babe. I don't know when Mom gets home. I'm on a phone
List
call.
of a bunch of stuff.
You need to go. I'll be there in a minute.
Can you see that, Michael?
It keeps jumping around. Okay, now I see where you're at.
Yeah. And then underneath Interactive Application Add-ins, I already added it, but there should be one that says Analysis Toolpack that doesn't have the VBA there. Can you see it on yours?
Oh, okay, sorry. I was just looking at your screen. Okay.
Oh, yeah. Anyway, there should be, go here, there should be one that says Analysis Toolpack. There's two of them, one that says Analysis Toolpack and the one that says Analysis Toolpack VBA. You just want the Analysis Toolpack one. You'll select it and then hit Go.
Okay.
And then you have to hit OK, I don't know. I think so. I don't remember. It's showing up here.
Here,
Oh. Yeah, hit Go, and it'll pops up with a thing that says Add-ins.
Uh-huh.
And you're going to check the box that says Analysis Toolpack. And then hit OK on that.
Would you be able to, because now I'm on it on my computer, would you be able to walk me through it? I'm not gonna look at your screen, but I'm gonna look at mine while you say the steps.
Sure, where are you at?
Okay, so now I need to click account or options. It's one of those, I think.
Yeah, so you're on, oh yeah, go to options.
Okay, there we
Then
are.
go to add-ins.
Add-ins?
Yep. Go to the bottom of the left.
Okay.
And then it'll show up with a list. And underneath the interactive application add-ins, right underneath there, it should be one that says Analysis Toolpack.
Oh, right, analysis toolpack, yeah.
Yep. So click the one that doesn't say VBA on it. There's two, and you want the one that doesn't say VBA.
Mine's
click on
the
that.
top one. Uh-huh.
Yeah, the top one. And so you'll click on that, and then near the bottom there's a button that says Go.
Okay.
Click on that.
Okay.
I did
And it'll
one.
pop up with a thing that says Add-ins, and it should have 4 checkboxes on it.
Yeah.
And you're going to check the box that says Analysis Toolpack,
Okay.
and then say OK.
The one without VBA, right? Just
Yeah,
the normal.
the one without VBA.
Okay.
And then hit OK on that.
Okay. And now it should work.
And now if you go over to the Data tab, there's a Data Analysis thing there.
Where would it be? I see like a data validation.
It should be on the
Data analysis. There it is. I found it. It's on the far right.
Yeah.
Right.
Yep.
And then now, do I look for a histogram or something?
Yep.
And then, so it's saying input, like input range and bin range. Is that referring to the column or?
I don't know. I'm trying to figure that part out right now. Data analysis, histogram, okay.
By the way, is the histogram simply that the graph that you can make with that thing they give you, like, you know, the Excel formula thing? I forget what it's called, but in one of the beginning lessons they let us they gave us an Excel uh, document thing to open up, and you could just insert the numbers and it'd make you a graph. Is that what we're supposed to do right now?
Yeah, you can probably just do that.
Yeah, you just select the area, select the information that you want, and then you just click on the histogram. Sorry, I got a little puppy.
Oh gosh, I don't know why.
Yes.
I'm on my Mac. I can't use my work computer for it, so it's all locked down for dumb reasons for my stuff, my work. Stop. Oh, come here.
Here's the histogram I came up with.
Marley!
So basically, if you take and select the data you want, and then go to data and data analysis, it's a histogram range. It might be pre-populated. If it's not, you might have to select it. Here's a little thing next to it.
So when I when I highlight the numbers I want, and then I click that, it's asking me for the range and all that. Like, what did you put in for that?
So for the, I just put the input range in, and that's from, so like I click on this, and then I go through and just select all of those numbers. Say enter, and then just say OK.
Got it. Okay.
And then it's going to make, this is the confusing part, it's going to make another spreadsheet that just has like a table in it. Like it doesn't have a chart yet. But then if you select that, you can turn that into a bar graph.
Right, okay.
All
right.
Insert bar graph, and then it's a histogram because it's based on the frequencies.
Okay.
Anyway, that was difficult.
That was a long one. All right. Do you guys want me to read this one?
I'll do it.
Okay.
Jessica Meir and her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body's temperature. The body temperature of seals tend to decrease as they dive. The researchers estimated that typical body temperature of each seal at the time they initiate a dive, and called this a representative temperature of the seal. Thermistors were placed in the hepatic sinus of the 4 seals, named Bottle, Roberta, Larry, and Purr. The seal's body temperature at the start of the dive was calculated to be, and then we have those. Complete the following table and answer the questions 12 through 15 below. So,
oh boy.
What is the value of the number that goes in the position marked as an A in the table above? Round to the nearest 3 decimal places.
So we got to start with finding the average, right?
Yeah. Somebody read those real quick. What are they? 37.91.
91.
Uh-huh.
And then 37.25, 38.98, 38.16, and divided by 4. What did that come out to?
So 152.3 is the total average, and then take.
I think you need to divide that by 4.
Yeah, I am right now. Sorry.
Oh, okay.
So 38.075.
Yep, that's what I got.
Now, do we do 2 decimal places or 3 for that? Oh, 3,
It
right?
says 3, yeah.
Okay. And then does
What
that
is the
come out?
value? Oh, sorry, go ahead. Sorry.
I think A is negative 0.165.
Yes.
Okay. And then
That's what
we
I got.
pretty much need to do the same to find B, but then with that extra step, right?
Yep.
So A is what? A is negative?
Yeah, negative 0.165.
0.865?
Yes.
That's for 11.
Yeah.
Negative 0.865. Okay.
No, wait,
We
wait.
need to put the 0 in front of the...
Negative 0.165. Is that what you have?
That's what I have.
Wait, negative...
0.165.
Oh, I put
Yeah, it's
8. Okay.
this number.
Okay. Negative 0.165. Okay, yeah, that's fine.
Okay, and then 37.25 minus. And then the average was 38.075, I think.
Yep.
Yes, yeah.
And that squared, I got 0.681.
Yep.
Cool. Okay, so the quantity is equal to the sum of the numbers in the squared division column. Or what quantity is equal to the sum of the numbers in the squared deviation column?
Variance, isn't it?
Yes. Yes.
I'm sorry, guys. What was 12?
12 is 0.681.
Do we need to put the 0 in front of the decimal?
Oh yeah, yeah, I always forget that. I should do that, right? All right, and then 13, I think it's the variance.
I concur.
Yeah.
Okay. What is the standard deviation of these temperatures? Oh, geez. Oh no, you just take the square root, huh?
Yeah, so you'll take the sum of all the squares, and then take the square root of it.
Oh, so we have to really fill out the whole chart, huh?
Yeah, if you want, I can show you what I did.
Let's see.
But yeah.
Oh, there you go. So you just used Excel for that. That's a good idea.
Yeah.
Yeah, I'm ready. You can check to make sure it's right. So I just took, these are the values, right?
Yeah.
And then we just did this value subtracted from the mean. And then this is just that value squared.
Mm-hmm.
And I just did that for all of those. And then this is the sum of all of those values.
Then that's
This is the square root of that number.
So 1.239.
Yes. That's what I got.
1.238. Okay, so 1.239. 1.239. Okay.
Under certain conditions, the standard deviation can be negative. That's false, right?
Nope.
Okay.
So squaring everything is never going to happen.
So it never be negative?
No, I don't think so.
Nope. Yeah. because then since we square, that's the whole reason that we square it basically. Is
Oh,
right.
because yeah, then yeah, that's true.
Yeah, good point.
That's good.
Okay,
All right.
so in the same study, the researchers placed thermometers in the 3 seals near the spinal cord and brain in their bane. They placed thermistors in 6 other seals in their aorta, the largest artery in the body. Finally, they placed thermistors in 4 other seals in their hepatic sinus. The results from this study are summarized in the table. Okay, so which
Are we in like biology or something? Or is this
I've never heard of any of those terms, so
the aorta? That's the aorta. That's like the main. Yeah.
yeah.
That's funny.
So
I'm glad you read that because I was struggling on the last one. Okay.
all right.
Mine is up next, right?
Yeah, I think so. He gets a short question though. You get to read the next one. So
You
it
get
says.
to read number 9. You get to read number 20.
Is that one a good one? All right. So which location resulted in the most consistent temperature measurements from one seal to another? So for that, we just want to find the smallest standard deviation, I think. So the extradural.
Extradural.
Whatever that is.
Yeah.
I can define standard deviation in my own words. Yeah. So standard deviation, it's just the distance between the distance
the difference
between the
between
values.
2 numbers, right?
Yeah.
So if you have 40 and 38, what's the difference between those two, right?
Just 2. Yeah.
It's the average distance from the mean of the data.
Yeah. The average distance. Okay.
Of the mean. Oh, okay. Okay.
So.
I like that.
Does anyone want to read 18?
Oh, I'll read.
Yeah.
The number of hours
The
students
number of
spend
hours-
studying for an exam. You get 20, dude. You get 20. All right, this is mine. The number of hours students spend studying for an exam were recorded. The data are represented by a box plot below. Use the box plot to answer questions 19 and 20. What is the third quartile?
I think it's 8.
Yep, 8.
All right, 8. What percentage of the data lies between 4 hours and 8 hours?
Now I think this comes down to that, what is it, 68, 95, 99.7 thing?
No.
Oh, that's for Z-score, huh?
Yeah.
Not,
I think it's just 50%.
That's for, yeah.
How do you find this one?
Well, so it's the quartiles, right? And so if I remember correctly, between like Q1 means that 1/4 of the data is below that.
Right.
And then
Yeah.
Q3 is 1/4 of the data is above it, right?
Yep.
So that would mean that between 4 and 8, 50% of the data are in there.
Got it. Okay, because for between the third quartile and the max or whatever. That's
because the third quartile is ending at 8 basically, and after 8 to 10 would be the fourth, correct?
Or 8 to 12. Yeah. Even though the line is longer, even though that's a longer line, that it just means that 12 is the max score, right? But then what's that other dot? Is that an outlier?
Yeah, I think they barely talked about that, but that's considered an outlier, and so they basically didn't they
didn't even bother
it from the mean.
Okay.
So 2 to 4 is the first quartile, right?
Yes, and that's
4 to 6 is the second. 6 to 8.
Yes. So 6 is the median, which is also the second quartile. Yeah, I think. And then 6 to 8 is the third. And then 8 to 12 is the fourth.
Yep.
Okay. So that representation is 50%, are we saying?
Yeah. 4 to 8, yeah.
Are we doing 5.0 or 5.0?
Just 5-0, because they have a percentage sign, so.
Oh, okay, yeah.
So I think Bryce had this one, 20?
Bryce is up!
An observation from a normally distributed population is considered unusual if more than two standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations, above 10 parts are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million, and values outside of this range are unusual. We will assume 1.5 or 1.59 parts per million is the value of the standard deviation, or the mean minus 2 standard deviations, and that the mean plus 2 standard deviations is equal to 2.52 parts per million. And it is reasonable to assume the measured nitrate concentration is normally distributed.
Oh boy. That's a lot of information. All right. So one piece at a time.
Use for questions 21 and 22.
All right. Estimate the mean of the measured nitrate concentration. The mean. Okay.
Let's see if we draw that one there.
Oh. Then we just have to do 2 more like it. I've never touched your computer. Nope.
So for the oh, nothing.
No, but you can. I was going to say, so in order to find the mean of the measured nitrate concentration, we basically want to just take 159 and 2.52, add them together, and divide by 2, because it's saying
give you
that
the
those
mean.
are standard deviations away from the mean, so the mean's going to be in the middle of them.
Right.
So it's 1.59 plus 2 point what?
2.52.
Yeah, plus 2.52. Divided by 2, so I got 2.055.
2.055. I got that too. So I believe that's right, but so what does this mean? It says the city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52. Oh, so it's somewhere between there.
Right. So if we add them and divide by 2, we'll get the mean, right? So.
Yeah. And the key part is it says that we will assume that 1.59 is the value of that U thing minus 2. So they're assuming that that's the value of the mean minus 2 standard deviations.
Okay. Yeah.
Then they're saying that 2.52 is the mean plus 2 standard deviations.
Got it. So anything between 2 standard deviations is what, 95% of everything?
Yes.
Okay. So the mean for 20 it's 2.055.
Yes.
Okay. Then estimate the standard deviation of the measured nitrate concentration in Rexburg's drinking water. Um,
So let's see. We know that the mean is 2.055.
yeah.
If we just plug that into what they gave us, we can say that that's minus 2 standard deviations, and we know that that equals 1.59. Correct?
Yeah. So is there a way to? Oh, maybe we could plug that in and find what the standard deviation is. So
The standard deviation between 1.59 and 2.52 is 0.65. Is that what we're looking for?
What's that?
Are we looking for the standard deviation between the 1.59 and the 2.52?
Kind of. We're looking to find out what the standard deviation is of the data set given the information they gave us. And so we're just trying to think, because it tells us that these numbers are 2 standard deviations away from the mean. We want to know how much 1 standard deviation is, basically.
Okay.
I think I got it. I think it's 0.23 or yeah, 0.233. So I did that by doing I did the U sign is we determined that was 2.055 and then minus 2 standard deviation equals 1.59 and then just by plugging that in and working it out I got 0.233.
Yeah, that's what I got too.
Okay.
That makes sense, Jason.
Yeah.
I can explain it. We kind of flew. We just did a little bit of algebra, which is kind of sounds funny. But we know that this whole u minus 2 standard deviations equals 1.59, right?
Right. Sorry, I went into another room so I could hear.
Oh, no, that's all cool. Actually, let me share my screen so that it makes sense when I'm pointing at. Okay. Can you kind of see where I'm pointing?
I don't see anything right now. Yep, now I do.
Okay. So the part that I highlighted is basically what we used to figure it out. And you could have used the other part, that's okay. But now that we know, because we know what the mean is now, right?
Right.
Which is what that whole u thing is. And so this is essentially an equation where it's saying 1.59 equals u minus 2 standard deviations, right?
Right.
Well, if we put in 2.055 there, then all that's left is the standard deviation. So then we just solve for the O, and that tells us what it is.
Okay.
Anyway, that's the way I thought of it. That might be more complex than you want to.
So did you use your Excel sheet on that?
Kind of, just to be able to divide, just to add and divide.
Oh, okay.
I just
Now,
plus and divide with that.
For 22 it says between what two measured nitrate concentrations do approximately 68% of the data values lie? So we need to find one's one z-score.
No, we should be able to. So it's asking from between what two measured nitrate concentrations? Yeah, the 68. So that would be 1 standard deviation away from the mean, correct?
Yeah, I'm just confused because I'm not seeing 0.233 there.
Yeah. Well, that's what the standard deviation is. That's not the actual number of how far it is from the mean. So we take 2.055 and add 0.233 to get the high value, and then we take the mean and subtract it to get the low value.
Gotcha. So I'm thinking it's the second one because So we got the mean as 2.055 plus our standard deviation of 0.233. That's
Which would be
2.2.
2.288.
Yeah. Yep. And then if we would have subtracted 0.233, it would have been 1.822. So
Yeah.
I think that's the right one.
That was the third one down.
Mine's the second.
Oh,
Yeah, mine's the second.
It might
Mine's
just be
the third
different
one.
order. Yeah.
That's weird.
Okay, so what is the value of the mean of a standard normal distribution? Value of the mean of standard.
Tiger, I need you to go out. I'm on a class. Tiger. I'm going to count to 3. 1, 2. Thank you.
I don't know what that means.
Yeah, I'm pondering that one. What is the value of the mean of a standard normal distribution?
What was the question on the homework?
What is the value of the mean?
What number is it?
23?
23. Oh, I thought that this wanted the equation. It says, what is the mean and standard deviation of the standard normal distribution? Oh! Is it 1? No, I'm confused. Wait, the mean should be 0 and the standard deviation should be 1, because I think that's showing that the whole z-score thing. I think that's what the standard normal distribution is. That's the only thing that makes sense. So I always think, when I first read that, I was thinking the sample mean.
Yeah. So what is it asking for? I don't get it.
So you know how when we do z-scores, we're using the standard normal distribution. So it's a bell curve that's centered around 0.
Okay.
Then you label like 1 and -1, and 2 and -2, and 3 and -3.
Oh,
and those
so
are the standard deviations away. So I think all it's asking is saying, if you were to graph that, what would the mean be? Well, the mean is 0, because that's 0 deviations away from the mean.
okay.
And then each tick mark that you put on there is 1.
Okay. That makes sense.
So that's where 68 and the whole 90, whatever. I don't know, that's the only thing that makes sense to me.
Yeah. I mean, that one had me stumped.
Yeah, I'm... That's a really vague question.
Yeah, when I read that question before, I was thinking, oh yeah, it's just the mean, and then the standard deviation is the standard deviation divided by the sample size. But that's not for the standard normal distribution. That's for the sample mean.
All right, I'll put 0.
And 23 and 24 don't even apply to that above question. So it's...
Well, 24, what is it asking? It's saying, what is the value of the standard deviation of a standard normal distribution? Huh. What is it?
1, because we put those tick marks 1 deviate, and the value that we put on it is 1 away.
So each one is just a value of 1? Is that all it's saying?
Yeah, I think so.
Okay.
And that makes sense.
Right.
Remember when we did all the z-score stuff? And how a z-score is like typically between 0 and 3?
Right.
It's because we're throwing it onto the standard normal distribution graph.
Okay.
I think. I don't know.
No, that makes sense. I think that's what it's asking for. I mean, if it's not that, then I have no idea what it's asking for.
Yeah. I'm totally just using my test taking skills on that. I don't know what the answer is.
All right, I got 25. So are we saying 1 for 23 and 24, right?
I'll probably need the applet for the rest of these. Huh?
What's that?
Oh, I just thinking. I just looking at the next, like the rest of the questions are all based off of what you're about to read, and we're probably gonna need that applet thing.
Man, this is a long quiz.
I don't know, man.
A little
Yeah,
too
my
long.
wife's like, you need to get done because I got mutual.
Oh, gee.
Let's do it.
All right, let me read this question. The admissions committee for most Masters of Business Administration MBA programs require the Graduate Management Admission Test, or the GMAT, as part of the application for new students. It has been shown that the scores of the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program in the school accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. What is the probability that a randomly selected student with score above 542.3 on the GMAT?
Okay, so it's saying, what is the probability that a randomly selected student will score above 542.3? Okay, so we need to start by finding the z-score, right?
Yeah.
So
Yeah.
542.3 minus
This,
the average.
The mean, which is 542.2.
right.
Oh,
So 0 divided by 120.54?
yeah.
Yeah, 120.54.
So that means the z-score is 0, so it's going to be 0.05.
Wait. How you get 0.05?
I jumped. Throw it in the applet, and you'll see.
Okay, so I'm going to put in a z-score of 0, and we just want the greater, so it's 0.5. 0, 0, 0.
Oh, yeah, sorry, 0.50. Oops. How can we check that?
0.500.
So that's a 50% chance. It's just
That's a big, yeah.
Okay, so
Yeah, on 25 it says rounded in nearest tenth, so I think it just went 0.5.
okay, 0.5. Got it.
0. Oh, okay, yeah, sorry. Gosh, I always
Just-
forget
just-
that 0 in front of the decimal.
Same here. So then
26.
now with that same equation, let's plug in 600 and go from there.
Yeah. Sorry, I jumped.
I know this is random, guys, but this is the best puppy in the world. Highly recommend a Maltese.
Let's see it. Oh,
Okay,
is it a
come
boy?
here. Come here. Okay, look. He's a dude. Really? He wants to play right now.
He's getting camera shy.
He's a Maltese. He's like 6 months old.
Awesome. Do you have one dog or do you have multiple or?
We have one dog and we have a tortoise.
Oh, sweet.
Yeah.
All right. Okay, so I got a z-score of 0.479. Now we got to plug that in.
Which rounds to 0.48.
Okay, and I get a 0.684 probability or area.
Wait.
What is it? 0.
Yeah, that's what I got.
0.684.
684.
Okay. So 600 or above, so we just move the thing around and we get 0.316 for 27.
Yeah, that's what I got. 316. Yep.
All right, and now it wants the 10th percentile.
What's 27?
Let me see. 0.316.
Oh, okay.
And then for 28, it's asking for the 10th percentile. For this one, I forget. Do you just for the area on the applet, do 0.1?
Yeah, but make sure it's the area below the bar.
And then for the z-score, is that negative 1.282?
Yeah, that's what I got.
And so we have to find the GMAT score that corresponds to that.
Yes.
So
we're going to take that multiplied by the standard deviation, and then you add the mean.
Which to mean is 542, right? Yeah, 542.3.
yeah. So we do negative 1.282 times the standard deviation, right, of 120.54.
Yes.
Yes. Yeah.
And then add the mean, 542.3.
542.3.
All right, let's see what that is. I got 321.953.
I got 388.
Uh-oh. Okay, let's see.
Let's see. So I took negative 1.282.
Yeah.
Is that right? Multiplied that by 120.54. And then I added in 542.2.
0.3.
0.3.
0.3.
Okay, well, either way, now when I did it again, I got 387.768.
Yeah, that's what I got.
Okay.
And it says round to the nearest whole number, so 388.
Okay, got it. There we go.
388?
Yeah. So that would be a bad score, apparently.
Yeah. When nobody under 500 gets in.
Yeah. All right, so 90th percentile. Okay. Does it matter if oh, it's the same. It's the same thing, just not a negative number,
Yeah, that's what I got.
not a negative z-score.
No, Mom didn't get chocolate.
Yes, she did.
That doesn't make sense.
Did you get 696 point? Oh well, 697.
Yep. Why did you do that?
Man, these questions just don't end.
All right, find the first quartile of the distribution of the GMAT scores.
So just do the 25%, right? 0.25.
Right.
And I get for the z-score negative 0.674.
0.25. Oh, darn. 0.25. There you go. Negative 674. Yeah.
Negative 6.
Then I got 461.
Yep. 461.
Okay. Find the third quartile of the distribution of the GMAT scores.
So, points.
5?
Oh, you know what? Yeah,
It's the same, just without the negative.
that's what I was thinking. Yeah.
That's what I got when I plugged it in. And I got 624.
624, yep. All right.
That seems easy.
Consider a simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of sample mean scores for all such samples? Round to the nearest tenth, 1 decimal point. So is this, it's just the normal mean, right?
Yep.
So 542.3?
Yep.
Okay. And what is the standard deviation of the distribution of sample means scores for all such samples? Same thing, right? 120.
120.3, right?
What's that?
120.3, right?
120.54. I think.
No.
Oh, yeah, sorry. It was
Divided by the square root of the sample size.
Oh, that's right. Okay. So 120.54 divided by square root of what, 15?
Yep.
And that's 31.123.
Yep, that's what I got.
So 31.123. Okay.
All right. What is the probability that the sample mean GMAT score for a SRS of n equals 15 students will be greater than 600?
Oh. Wait, didn't we already do this one?
Yeah, what is the probability of the sample mean GMAT score?
What? Well, we on 26 we said what is the probability of a randomly selected student will score 600 on the GMAT?
Yeah. So okay. So what we need to do is that formula.
Sorry, just 27.
I think it's 600 minus the mean, right? Or 542.
542.3.
And then it's that thing where it's 120.54 over the square root of 15.
Oh, finding the z-score. Gotcha. So we'll take 600 minus 542.3 divided by 120.54, and that's divided by the square root of 15.
Yeah.
Gotcha. So that is going to be 600 minus 3 divided by square root.
All right. I got the z-score as 1.854.
That's what I got.
Not even a 2% chance.
Well, then I think we still need to throw that on the applet, right? I think.
Yeah, that'll be greater than 600. Or greater than, I got 0.0319.
Yeah, yep. So 032.032.
0.0.
32. That was long.
That was brutal.
Yeah.
All right. Let's submit this thing. See what happens.
Okay.
Did I answer everything? Yeah.
88. Oh, we got number 3 wrong.
Oh, dude, I didn't turn mine in yet. Let's see what they're.
Oh yeah, go back and change it.
No,
Dang it.
I got a 91.
Oh gosh, what happened?
I don't know. Maybe.
Oh man, you know what? 3 was my fault. I was so I was stuck on that one. You know.
Okay, I got 23 wrong.
Let's see, what was 23? Oh man, I got 13 and 14 wrong.
Yeah, I got those wrong too.
And then
Yeah, so did I.
23. What did you do for that?
We put 1, right?
No, we did 0, then 1 on 24.
Okay.
Dang, I'm sorry.
It's all right. And then 13, we.
I thought it was a variance. Huh.
Wait a minute. What is it saying, the numbers? Maybe he's talking about the actual values.
What are you saying? What do you mean?
Oh, JJ, sorry, I might have cut out. Did you hear me?
What's that?
Can you hear me now?
Yeah, I hear you.
Oh. I must have cut out.
Hey,
Anyway,
sorry guys.
oh, that's all right. I was just saying, the question says what
You there?
quantity is equal to the sum of the numbers? And I just realized it just says the numbers. And so I'm guessing he's saying if you added up the actual like 37.91 and those, then what does that mean? And it really means nothing. And
What?
so when I read the numbers, I assumed that he meant for some reason the I don't know why I assumed it, but I assumed that it was the squared deviations that we just completed in section 12, number 12.
Right.
I'm pretty sure that is the variance, but I think, I don't know, maybe by the numbers he meant the representative temperatures.
All right.
I don't know. Why do we get the standard deviation wrong? I don't understand that.
Yeah.
I should have put it in the standard deviation function to begin with and just seen what that said.
Man, that was a long and very long test.
Remember the standard deviation is 0.715.
All right, guys.
All right, man.
Yeah.
See ya.
Good luck on the test.
All right, man. See ya. Bye.
Later.
I don't know, what did we screw up? I'm gonna...
Yeah. Yeah. Well, I'm kind of confused about the one. I really thought I was right because when I was studying, I looked up the definition of parameter and statistic. In the video, it gave an example that was very similar to that. And they were saying, well, they had an example of, I guess, a parameter or statistic of everyone in the United States. And they said, well, clearly they could not have, surveyed everyone. So it must be a statistic because a parameter is when everyone is surveyed. So I don't know. Oh, well, I guess.
See, I think what happened was it just depends on how you think of it entirely.
Yeah.
Because, I mean, here it's saying that the mean IQ test score in the United States is 100.
So it's saying it's a fact.
There's nothing in the wording that made it sound like they did any type of sampling. They're like saying, no, that's what it is.
Yeah.
Whereas the second one,
it's a parameter.
Yeah, whereas the second one said, we did sampling, and this is how we did it, and this is the mean of it.
So then the 112, it says, and the mean of their scores was 112. So how is that not a parameter?
Well, it's a statistic because they're then using that to extrapolate to all people in the United States. And so it's a statistic because it's not the population we're talking about in both is the United States people,
Okay.
right?
Yeah.
And so 100 is saying, assuming that they did ask every person in the United States, um, and that is the actual value. And then it's saying statistically we went and did a sample of 20 randomly selected statistics students to represent the entire U.S. population, and so then it's a statistic.
But it doesn't say they're comparing it. It just says 20 randomly selected statistics students took an IQ test and the mean of their scores was 112. Like it doesn't say it's comparing that to.
I know, that's why I'm like, it just depends on how you think it. I think the question could be more explicit because
Huh.
I think it's assumed that we're talking about the same value
Got it. Okay.
that we are trying to extrapolate to the US in both situations.
Yeah. All right. Well,
Yeah.
good luck on the test. Hopefully it's not this hard, but it
Yeah.
probably will be. But
Oh well, we'll still get a 91 on it. If we do.
yeah. Yeah, that's good. That's good.
Not bad.
All right. Well, I'll see you on Thursday.
Yeah.
Later.